how do you find an eigenvalue and eigenvector for a given matrix. So I'm going to take the matrix first one. So how do you actually find out the eigenvalue and eigenvector? So first, as per the rule, if I have a vector, if I have a matrix, there it's vector. If I multiply, it should be a scalar multiple of the same vector. Now I'm going to take this particular vector here. So it's lambda times I minus a. The determinant of this should be 0 as per the rule. And my equation that I write down here is, let's say, lambda times 1, 0, 0, 1 minus a is, let's say, 2, -3, -8, and a 0. So what we get is, this is lambda minus 2, then you get is positive 3, then you get 0 here, and you get 0, and this is positive 8, and lambda times 1 minus 0. So this is lambda. Now this determinant must be 0 if the eigenvector is a non-zero number. So this lambda times lambda minus 2 minus 3 times 8 equals to 0. So we get lambda square minus 2 lambda minus 24 equals to 0. So if I factor this out, I get lambda square minus 6 lambda plus 4 lambda minus 24 equals to 0. So I get lambda times lambda minus 6 plus 4 times lambda minus 6 equals to 0. So I get lambda is 6 or lambda is minus 4. So now for this vector, for these vectors, for these values, eigenvalues, so these are my eigenvalues. And for the eigenvector, I'm going to plug this lambda 6 here. So 6 minus 2 is 4. And 6, so this is 3. And this is, let's say, 8. And this is 6 here. And if I take, let's say, my vector as a and b, my answer should be basically 0, 0. So in general here, what I'm doing is actually 4 times a plus 3 times b equals to 0. And if I take b as t, I get a is -3 over 4 times t. So actually my eigenvector is -3, 4. And here, if I take it as 1 times t. So this is my vector x, and when my lambda is 6. So I could take the vector also as -3 and 4. So that's my vector. Now, if you notice that if I multiply this matrix to this vector, the answer that you get will be always a scalar multiple of -3 and 4. Now also let's take the other value, which is lambda equals to -4. If I take lambda as -4 here, what I get is basically, so -4 minus 2 is -6, 3, 8, and -4. So times a and b, and this answer should be 0, 0. So if I multiply it out, so -6a plus 3b basically equals to, let's say, 0. So now here, if I take b as t, I get a is 1/2 t. So that is, my vector is half and 1. And if I take as a scalar multiple, which is going to be 1 and 2. So if you multiply these metrics by any vector that is scalar multiple of 1 and 2, the answer is going to be always a multiple of 1 and 2 itself. So for example, if I multiply 1 and 2 with this matrix, your answer is going to be simply the multiple of 1 and 2. And that